Hello everyone, welcome to today's class. In our last class we started the topic water, and we saw that water is a universal solvent and also is used for so many purposes. We went on to look at the sources of water, which are the natural water and treated water. Examples of the natural water, we have the rainwater, the spring water, well water, and so on and so forth. For the treated water, the examples are distilled water, we have chlorinated water, and the pipe-borne water. And furthermore, we looked at the structure of water in details, whereby we were able to arrive at the structure of water having a bond angle of 105 degrees between the two hydrogen atoms bonded to water. And most importantly, what we saw as a conclusion of the structure of water is that in that same structure of water molecule, it has two lone pairs of electron and two bond pairs of electron. In today's class, we shall be looking at the types of water. Now, talking about the types of water, we have mainly two types of water, and they are: one, soft water. Then secondly, we have hard water. Now, what are soft water? Soft water forms lather with soap easily. Now, when we make use of the word lather, what is that? Lather simply means foam. That is the ability of that soap to form foams in water when soap is added to water. Now, examples of these, we can have rainwater. Distilled water can also function. And of course, we have our borehole water, and so on and so forth. Now, the next one is hard water. And hard water does not form lather readily with soap. And so for that reason, it becomes a little bit of a problem, because here it means that you are going to use a lot of soap in trying to form your lather for any purpose you intend using it. And that will take us to hardness of water, because we need to understand exactly what is responsible for the hardness of water. So let's quickly look at hardness of water. Now, I did mention earlier, and I said that water that does not form lather readily with soap, they are known as hard water. Now, this property is what is called hardness of water. Hardness of water. Now, water acquires its hardness by simply dissolving calcium tetraoxosulfate 6 dihydrate. So in the chemical formula is CSO4 dot 2 molecules of water. Or it can also dissolve calcium trioxocarbonate 4. Now, these are what causes our water to be hard when it is dissolved from the soil from which the water flows. Now, if I want to further explain the two that we have, calcium tetraoxosulfate 6 dihydrate is slightly soluble in water. But that of the calcium trioxocarbonate 4 is insoluble. So what makes this man to be slightly soluble in water, I beg your pardon, is that when that water contains carbon 4 oxide, then carbon 4 oxide has the ability to dissolve calcium trioxocarbonate 4 and to make it a slightly soluble substance of calcium hydrogen trioxocarbonate 4. And so the equation becomes this. Now, this is actually depicting that you have carbon 4 oxide in that water, which is actually dissolved. And so this man has the ability to make this calcium trioxocarbonate 4 dissolve to give us calcium hydrogen trioxocarbonate 4. Now, at this instance, the calcium hydrogen trioxocarbonate 4 is now slightly soluble in water. And so to this extent, I am going to now list the substances that we have, or rather the dissolved salts that are in water that makes it hard. And we have it as a general principle that we have the substances responsible for hardness of water are, we have calcium, this, or you can have, in place of that, you can also have this. That's one. Then the second one is calcium hydrogen trioxocarbonate 4. Now, when you have these substances in water, it makes the water hard. In other words, causes hardness of water. However, when we add soap to it, because the essence of we having our water is for domestic use and as well as industrial use. Now, if you have these substances, if you have water and you add soap to water, what happens is that they will form what is called scum. Now, scum is like a whitish or rather a milkish substance that forms on the surface of clothes. Now, I have this experience when I was young. I had to use hard water in trying to wash my clothes, and when I added soap to it, of course, you see that these scums, they will react or rather form on the surface of these clothes. And if care is not taken, those scums can spoil your clothes. Okay, now if you add soap, the essence of actually having your soap in it is that you want to remove the hardness of that substance in that water so that your soap can form lather for whatever purpose you intend using it for. Now, the soap that you want to use has a sodium or potassium salt of an organic acid. And so if you try to react it with that, sometimes the example of that soap is sodium octadecanoate. It's a complex compound. So that's the chemical formula. Now, if you decide to add it to your water containing any of these substances, this is what will happen. If I have C, so when you add your soap, now the soap is this. To water, this man initially is soluble, remember, and this is also soluble. and it's also your soap. So let me just write soap instead of sodium. So now we know that that's our soap. Now, what is the essence of this is that we want to replace the calcium ion or the magnesium ion that causes hardness of water. Immediately you are able to remove that, right? Lather will form. And so if you replace that with sodium, now you are going to have the next compound as C17H35 COO to this plus. Now remember that this is also a replacement reaction whereby sodium, of course, displaces calcium. And so in this case, this man becomes insoluble, and while this man is soluble. This can be filtered off to allow the sodium perform its function in whatever purpose that the water is being carried out for. Now at this point I am going to stop here. If you have any questions, you can send them to my private chat and I will answer you. Thank you for listening.